Hello, my name is Matthias Ernst, and in this presentation I want to give you an overview about our cloud computing capabilities and how you can use them without paying any additional fee. Let's get right into it. First, short introduction, and first question, who's Dassault Systèmes? Dassault Systèmes is the second largest software provider in Europe, and we are offering software especially all around engineering and development processes. We offer a lot of different softwares in many domains, and these are organized in the brands that you're currently seeing all around that compass that's in the center. We come back to this later. But these different brands focus on certain domains. And for example, most of you might know the software SolidWorks. We have the brand SolidWorks, which takes care of that software, and additionally other software tools all around SolidWorks. Similar, we have CATIA as a brand and as a software. And we also have, for example, the Simula brand, which takes care of a lot of simulation software tools. We have Dermia, for example, is all around manufacturing processes, manufacturing tools, and so on. Enovia regarding data management, and so on. So we have many different tools. They are organized around the compass, and the compass is the binding element and brings those technologies together. We will talk more about that a little bit later. Now let's talk about simulation. We have multiple simulation tools in our company, and I've tried to show and organize them regarding their target audience. So at the left side, you see different user groups and what kind of simulation tools they would use. Be aware that these different categories, they are not rigid, so it's kind of floating, and user might be part of maybe two of these domains, so don't see them too strict. But let's take it like it is, and of course, for designers, we have our CAD integrated tools. So in CATIA and in SolidWorks, we have simulation tools specifically targeted to their users. So they are directly embedded. They have the same user interface, same usage principles, and they are perfectly suited for this kind of audience. But when you want to go into a more advanced domain, then those tools are not suited. They are built for designers, so really made easy to use and up to a certain capability. Beyond that, we have our more specialized tools coming from the Simula brand. So for structure simulation, we have, of course, Abacus, the most powerful tool for nonlinear structure simulation. We have Tosca for optimization, FESA for durability calculations. For fluids, we have PowerFlow and XFlow, so overall CFD simulations. SimPeg for multi-body dynamics. For electromagnetism, we have CST and Opera. Wave 6 for vibroacoustic simulations. And in the other domain here, we have iSight, which is a tool that can be used to automate processes across different applications and then do parametric optimization also. And we have Daimler, which can be used for system simulation. Maybe you know that with the name 1D simulation also. So these are all different tools for certain user groups and certain tasks. They are all very good at what they do. But of course, we're not stopping the way they are, and we want to improve and enhance these tools. And for example, we want to make the transition easier, going from a more CAD integrated tool to a more advanced tool. So if a user grows and learns with simulation and then wants to do more, then at the moment he has to switch to a different tool with new user interface, different usage principles, and we want to make this transition easier, for example. Also make it easier to combine different tools that you're seeing here to make the best out of them, but also bringing new technologies into those tools and user groups, for example, allowing cloud execution. So how do we do that? Here we get to the 3DEXPERIENCE platform. Here we're bringing these technologies together to allow these kind of things, and To explain a little bit more what the 3DEXPERIENCE platform is, we take a few minutes and have a close look at that. So let's talk about the 3DEXPERIENCE, especially with the cloud infrastructure. So on a high level, what is the 3DEXPERIENCE platform? Well, it's an infrastructure that brings together different users with different tasks and processes, and allows them to work together independent of their location. That's the power of the cloud infrastructure. And so on that common platform, you can make most out of the data and really work seamlessly together without any import, export, and breaks in the data flow. So cloud, just one slide. A couple of years ago, the question would be, why cloud? I think today, and after things that happened the last 1.5 years, the question is more, why not cloud? So cloud has been proven very powerful in the private sector, where everyone is using cloud for different applications, and also in the business sector. And the advantages that the cloud offers are some of them are shown here, but I'm not going through all of them. But as mentioned, today every company should think about cloud and have a cloud strategy. But let's have a more detailed look what it means to use the cloud when you're working with SolidWorks and you want to do some advanced simulations. So to give you an idea how that looks like, using the 3DEXPERIENCE platform to combine these tools, and for such a workflow, I have a short video here. It is sped up, so it's running rather fastly, and I might not be able to keep up with my explanations. But also, beware, this is just showing a very small portion of what's possible with the 3DEXPERIENCE platform. So we're here really just focusing on the portion that uses SolidWorks as a CAD system, bringing the data to the 3DEXPERIENCE platform, using the simulation tools there, and then going back to SolidWorks, making a change to the geometry and updating that change again to the existing simulation in the 3DEXPERIENCE platform. That's the intent of that video. And so let's get started. So as you can see, regular SolidWorks, I'm connected to the 3DEXPERIENCE platform and I'm uploading the data, and to organize my data, I'm also putting them into a virtual folder. After the data is uploaded, I can directly then open the 3DEXPERIENCE platform, the desktop application that's connecting to the cloud with the data I've just used. And in this application, then I can create a simulation. We make a cut to save the time, and we go directly to the created simulation and to the results we've achieved. So we'll just have a look at the basic post-processing capabilities. Of course, there's much more possible, but we just had a brief look at the mesostress, doing an animation, switching the result variable, for example, to a strain, using a cut plane to look inside, and also then using an XY plot to have a look at the force displacement graph. Now we're going back to SolidWorks and we're opening up our assembly again from the cloud. We are reserving the data so no one else can change them while working on them. We're doing a modification. I've prepared that with working with parameters that I can directly change. They will modify the two cutouts in there, probably too fast to realize. And then I'm synchronizing my modifications back to the cloud, and then unreserve the remaining components so they can be modified again also by colleagues. And on the cloud, I kept the data open and I just have to refresh. We see the geometric modifications. We see that the mesh is not up to date. Now I have to just click on one button and refresh the definitions onto the new geometry, and I can directly submit the simulation again and then look at the modified simulation results. In this case, we have overridden the results, but we have also kept both of them. Now I'm in the browser. In the browser, I can also go to my data, find my simulation, and open the simulation in a web-based viewer that you see here now. There I can also do post-processing. So that's really suited when you're at home at the couch or on a business trip at a conference or at a trade fair. So with a tablet, you can log into the 3DEXPERIENCE platform, open the results, look at them. So really useful for all the users, especially the non-simulation experts like team managers or designers who are not doing the simulation. So really a simple web-based interface to look at the simulation results. So what have we seen is this really short video. We've seen that we've used SolidWorks to upload our design to the 3DEXPERIENCE platform, to the cloud. Then we've used the 3DEXPERIENCE client to use the simulation tool to use those data to create the simulation, run the simulation. We've opened up the geometry again in SolidWorks and modified the geometry and then updated the simulation based on that. And at the end, we have seen that we can also log in with the browser to the 3DEXPERIENCE platform, and there are many applications that can be used in the browser to interact with the data, do things. And in this case, we have only accessed quickly our data and used a viewer application to look at the simulation results. So this is really just a small glimpse of the capabilities. And what you've seen here, interacting from SolidWorks, so saving data from SolidWorks to the cloud and opening data from the cloud in SolidWorks, is not only possible with SolidWorks, but also with our other tools we're offering, so with CATIA, with DraftSight, for example. But we're not stopping there. We're not providing these capabilities only with our own tools. We're also able to do these things in the same way with external CAD systems. So we have similar interfaces within these other CAD systems to interact with our cloud infrastructure and to work on the data. And this is not only true for using one of them, so you can use multiple of them or all of them. And so you can create a true multi-CAD environment and to combine these different tools on a common platform and to work together. All right, now let's go a little bit deeper into simulation. So what is the goal that we want to achieve with simulation on the 3DEXPERIENCE platform? Of course, we want to connect CAD, so modeling and simulation, more seamlessly to allow easy transition, to allow associativity, and to make it either for one user, easy to use, simple, also to advanced simulation capabilities, or to make it easier to work together between these two domains when there are different users. The approach we're using with the 3DEXPERIENCE platform is model-based and data-driven. So we are creating models for various kinds of simulation and other kind of models based on the data that we have in the 3DEXPERIENCE platform. So we are not using files located in certain folders with a certain name that can change and that are hard to track and hard to recognize when something has changed. That's not the approach. We're using this kind of model-based data-driven approach to really put the data into the center of everything. Of course, we want to allow everyone to use the data. Depending, you can of course restrict usage and create spaces where only certain people can work on certain data. But overall, we want to combine users from different domains to have the same view on the data, to work on a single source of truth, like it's said. Of course, that's one goal. Regarding simulation, we want to make it possible to work on different levels. So we have simulation tools targeted for designers, so easy to use with certain amount of capabilities. But we are also supporting advanced simulation with the capabilities that are really going deep into the simulation technology. Of course, when using a cloud infrastructure, we are offering cloud computing. We will come back to this in the next slides. And what we are also offering and also working on in long term is to offer not only structured simulation or CFD simulation, but also much more domains and on multiple scales and new technologies to combine these kind of simulation technologies to make it easier, for example, to do co-simulations and different kind of things. But let's focus on cloud computing. Okay, when you create a simulation in the 3DEXPERIENCE platform, of course, then you run the simulation, you execute the simulation to generate results. And one way to do that is, of course, to run the simulation locally on your machine. Here, if you use the icon of a laptop, but it doesn't matter if this is a laptop or a desktop machine, maybe that's standing below your desk. of course, you can do local execution to generate results and then work on the results. But of course, this has been done the last decades, and working fine in many cases, but also has created some issues. For example, when your model is too large for your machine. So today, because everyone has to be mobile and working from different locations, many people are just working with laptops, and running simulations on laptops, can be a limit. And so, for example, your laptop or your machine overall, doesn't matter at the end, doesn't have the power to handle, for example, large simulations that are needed to really capture the essence of your simulation. Or the simulation is running too long, you want to have something more powerful that speeds up the simulation, or you want to run multiple simulations at a time. So one machine is maybe not enough for the amount of simulations you want to do, or one really simple reason local execution might not be good is just to keep your work environment quiet. So I'm sitting here next to my laptop, and when running simulation on a laptop, after some minutes the fans get loud to cool the system, and and a little bit later I'm annoyed of that, and so that's one reason I don't want to run longer simulations on the laptop that's here right next to me. Of course, then you can say, well, let's invest into some high performance computing, some hardware we are placing somewhere in our organization to run those simulations. Of course, that's an option, but that only makes sense if you're using, or if you're having this requirements to run large or many simulations, if you're having that really often. If you're just having that need only once a week or once every 2 weeks, and you look at the true cost that comes with your own powerful hardware, that doesn't make much sense. It's not really economical, and so that's only a real option for real power users that are using simulation, daily basis and have really high requirements. What we are offering instead is an alternative that you can run these simulations in our cloud, in our grid service. And what are we offering there? We are offering, of course, 24/7 capabilities to run simulations. We are offering specific infrastructure for high performance computing. So at the moment, we are offering capabilities to run a simulation with up to 404 cores at a time. So one simulation can run up to that number. And these are true cores, which means they are not using hyperthreading, for example. So if you look at your machine, at your laptop, you might see, well, I have 12 cores, but maybe at the second look, you see that these are only virtual cores because of hyperthreading. In reality, you might only have 6 cores. So in the cloud, we have true cores, no hyperthreading, so you can really use the power of these cores or CPUs. And that's a quite important topic, because at the end, with these cores, they really dominate the speed of the simulation. Okay, now let's have a look at the offering that we have. And you see here in that table, it's structured in those 3 domains: structure simulation, CFD, and electromagnetism. And in structure simulation, because there are different user groups, we are having a variety of those roles. If you haven't heard of roles, that's the concept we're using. It's a role-based concept. If you're not familiar with that, you can just imagine them as licenses. So we're starting with the role structure designer. So that's the role or license for, as the name says, for doing similar or simple simulations on designer level. So this is linear simulations, so linear static, eigenfrequency, buckling simulations with only solid structures, so solid elements, and a certain set of pre- and post-processing capabilities. The structure engineer then goes a step further. It's still limited to linear simulations, but you have full pre- and post-processing capabilities. Structure performance engineer then advances that with providing capabilities to do nonlinear static and nonlinear dynamic simulations, Then with the durability performance engineer, enhancing that with allowing, in addition, to do fatigue simulations. Structure mechanics engineer provides access also to the explicit dynamic simulation and some more capabilities, some really advanced capabilities like submodeling, substructuring, material calibration capabilities, parametric studies, and so on. And also then with the durability and mechanics engineer, adding the fatigue capabilities to that. Then we have a role for CFD simulation with the fluid dynamics engineer, plastic injection capabilities with the role plastic injection engineer, and a role using CST technology using with the electromagnetic engineer, allowing simulation in that domain. So with each of these roles, they are targeted to a certain user group, and with each of those roles, we are providing simulation capabilities when it comes to executing the simulation, so really running the solver. And you can see some roles are more targeted are for designers, have, for example, capabilities to run on 4 cores. Advanced simulation that need more compute powers can run on 8 cores or even 16 cores for CFD simulation. And you see, they can not only run that on your local machine, you can also run that directly with these limits on the cloud. This execution is directly included in that role, and there is no additional fee you have to pay to do that. There are certain limitations at the moment that will disappear in the future. For example, you see in the last line that the execution in the domain of electromagnetism is currently brought to the cloud. So in Q3 with the next release, we will provide that capability on the cloud. Also currently in work is the capability to execute the fatigue solver on the cloud. So with the role durability performance engineer and durability and mechanics engineer, you can only run the structure simulation on the cloud. When it comes to the fatigue calculation afterwards, this has to run locally at the moment, but it will come soon, targeted to the end of 2021, that this will also be possible to execute on the cloud. Okay, since there are a lot of information here on that slide, let's make it more clear on the next slide what that means. So what we are providing with these roles is to run one simulation at a time, either locally or in our cloud, without any additional cost. So that means you can run a simulation around the clock, so 24/7 in the cloud. And of course, for a whole year, that means you can run 8,760 hours of simulation in the cloud without paying any additional fee. But since simulation is not equal to simulation, so it doesn't matter, especially from an IT perspective, how many cores you use in the simulation. Let's make it more specific, and let's have a look, for example, at the role structure mechanics engineer, which comes with 8 cores, and that means you can run one simulation round the clock on 8 cores. So we are providing more than 70,000 CPU hours, even though we're talking about cores, but CPU hours is like a traditional term that's used. But we are providing this kind of CPU hours without any additional fee to every user using this role. Even twice that when we're talking about CFD. So since this fluid dynamics engineer role comes with 16 cores, we are providing more than 140,000 CPU hours without any additional fee. So you can run these simulations in the cloud and don't have to pay anything when you only use these limits. And so the question is not anymore, do I have to run simulations on the cloud, or do I want to do that? The question is more, why not using the cloud to run simulations? So for example, my case, when I estimate that a simulation I want to run runs longer than 15 minutes, then I'm not running that on my laptop here. Even if it's just a small simulation that can be run on my laptop, I am submitting that in the cloud, and I keep my work environment quiet, or I still then have the flexibility to reboot my machine or to power it down and maybe go to a meeting And so that's really useful, and it's a real big advantage. But what's possible when you want to go beyond these capabilities we are including? How to use more cores, for example, or to run multiple simulations at a time. So here's an example. When your workload, let's assume that time graph could be a month or a quarter, and you have different workloads regarding the compute capacity that you need when running simulations. Maybe when you have a project, maybe at the end you need more compute capacity than in other times. So what we are providing is, with this embedded compute that comes with the roles that we have seen on the previous two slides, that's what we call an embedded compute capacity. With that, we are covering the typical needs. So that is included without any additional cost. But when you also want to cover these kind of peak usage that you maybe have, there we are offering two possibilities. One possibility is to purchase additional tokens and then to use those tokens to run multiple simulations or to run simulations in general on more than the included number of cores. Tokens are non-consumable entities, so you have a certain set of tokens, and when you run the simulation and you need additional CPUs, for example, then you can use those tokens. They are blocked at that time when the simulation is running, and when your simulation is finished, the token become available and they can be used for the next simulation to make it also more powerful. Our colleagues can do them. They can use them. So tokens are most economical when you really have these peak usages quite often and regularly. If you don't have them that often, we are offering credit as an alternative. So that's more economical when you only have like once a week or once twice a week, every 2 weeks. The need for having more compute capabilities. The credits, you can imagine them as like a prepaid phone. So you purchase a certain number of credits, and they are consumed when you run larger simulations. They are consumed on a certain rate, and so that's the more economical thing to use when you only have occasional these kind of needs. Okay, and with that, we come to the end and summarize what we've seen in this presentation. So what we're offering with the 3DEXPERIENCE platform is powerful simulation portfolio built on proven technology. For example, these structural simulations using Abacus as the equation solver in the background, or using CST for electromagnetism, or FE-safe for fatigue, and so on. We have a scalable solution, so we have tools targeted towards designers, but we also have tools, or more specifically roles, for experts who really want to use some really advanced technologies. And of course, users can grow from one role into another, but also data can go from one application to another. So an expert can take the simulation that the designer has created and enhance that with features and functions, and to make it a more sophisticated simulation. So that's also possible. Of course, we want to bring modeling, so CAD and simulation, closer together, make the transition smoothness, keep track of the modification, keep the associativity, so that it's directly visible when input data are changing in the simulation, that when multiple people are working together, that the simulation guy, for example, can directly see when something has changed on the geometry. So really to have a associative interface, and not only between our tools, so not only, for example, between CATIA or SOLIDWORKS and our simulation tools, but also from external CAD systems, and to have that true associativity. And that's something kind of unique that no other tool can do. Of course, we are offering in that cloud infrastructure also cloud computing. The capability directly included in those roles is up to a certain limit. So what is defined as a typical need. So that means you can run one simulation at a time in the cloud without any additional cost. If you want to go beyond that, we are offering tokens and/or credits, so you can also use both at the same time to get access to more compute capabilities and to use that for more advanced needs in regards to compute power. But that's not all. So the 3D Experience platform, we have just here focused on design and simulation, especially on simulation. But you can do much more with the 3D Experience platform. You can, of course, use it for the whole data management system. That's the core functionality. And on top of that, you can do many more things like creating product configurations across multiple CAD systems, also do project management, so including different users, from different domains, the data, and to create projects where you can really keep track of what user is working on what portion of the project and what data he's using and what data he's generating. So that's really, when combining these things, that really brings out the power of the 3D platform. And then using tools also from different brands like rendering or manufacturing, or we have also tools to communicate in the team or in a project. We're working with colleagues, so you can create communities. We have included chat and phone conference systems. And yeah, so that are possibilities we haven't talked about here, but they are available on the 3D Experience platform. And with that, we come to the end of the presentation. In case you have any questions, you see my email address there on the slide. Feel free to contact me in German or English, and I will be happy to answer your questions. And with that, I thank for your participation, and I wish you a good day.